Hello, Ben at -9 Computing. Good to see you. Today I wanted to look at that WIZ light bulb, which is actually right here. It is made, I think they're owned by Philips now, but it's an IoT device and it comes with a little app and you can change the color here. I'll kind of show you, like, I don't know if you can really see that. Sorry, that doesn't look so great. But right now it's set to like lemon, for example, for this particular light bulb. And what I wanted to show was how we can kind of query it via the command line. And up on the screen, you'll notice over here, we're echoing, so ID of 1, and then method, set pilot. Some of these are different values, obviously. Now here's the parameters, which is more of an interesting part. So red value, we're going to set to 0 for red, 0 for green, and 255 for blue, and we're going to dim. So this will set it to blue. And then we're going to pass it to NC, which is netcat, -U, and then we're going to talk, this is the IP address of the light bulb, and then this is the port. And I guess you could kind of call this hacking. The light bulbs are on your private network or your internal network, so if someone does have access to it, they can go in and probably just install the app and do this. If not, they can do it this way. So boom, see, it turns blue. You know, kind of cool. And then I added a few, I kind of did a couple different commands. I just wanted to have them all queued. Okay, so that's not the right one. There we go. So I had a couple different ones queued, ready to roll, just so I don't have to type all this out. But it's kind of interesting. Oh, it looks like my screen kind of overwrote. Sorry, let me make that a little better. 1, 2, 3. There we go. So how secure are these? I guess if someone has access to your network, they can change your light bulb colors. There are known hacks that if you can get into the light bulb, you can possibly kind of crack into the system. And I guess some of the passwords for, say, your Wi-Fi are on the bulb itself, are stored. They should be encrypted and secured, but I don't know that they all are. There's some devices that are more susceptible than others. But part of it is you kind of already have to have access to the network to get to that. So I mean, it's possible at a business someone could unscrew a light bulb, take it home, wire it in, and then get the credentials. That's a possible vector of attack. But for our state right now, we're just fiddling with the bulbs. So here's another one. We're going to echo this to netcat to sort of send the command. We're just going to say, set the parameter state to false, which should turn it off. Now, remember, there's also a dim. So down it goes, it dims. And then ultimately the same thing would be true if we set it to true. So here I just changed it to set state to true, and the light comes back on. Very cool, very simple, but fun nonetheless. And then here's one that I'm not always getting results. Sometimes I do, sometimes I don't. Basically this one is doing SOCAT. So SOCAT is like netcat, but kind of on steroids. And it has some other features. Now what I'm trying to do is kind of blast a UDP user data protocol broadcast out on the network. Just, hey, anybody out there, respond. So I'm saying anybody on this network, 172.16.0, all IP addresses on this port, respond back. And yeah, I'm not getting a response. Earlier I was. I'm not sure why that works sometimes and doesn't others. Just haven't really spent a lot of time fiddling with it. I do have another Python script that I've been fiddling with that does similar stuff, and why don't I show you that too? Kind of fun. Okay, so here we are. This Python, we'll call it a bundle, is PyWizLite. Yeah, I got it on Github, and I will put a link to this in the description. But it's kind of cool. It comes with some different scripts and some that I fiddle with. I'll just show you one real quick right now. Kind of what I was trying to do before is do a broadcast and see what's going to respond, and I couldn't get that working. But here, it does it a little differently. So we're going to say my network's 172.16.0, and I'm going to say 255 to kind of broadcast all the addresses, all the bulbs, and we're searching for them. Bingo. So there's 3. These 2 I think are my outdoor ones. Found them. And then this is the one that we were just, I can tell by the MAC address. These are the MAC addresses. And that's very handy for targeting them. which is something I've been also working on, is creating a deauth to basically knock them off the network. Just kind of, you basically send packets to the access point they're connected to saying, oh, I want to, deauth me, drop me. And it basically drops devices off the network. I don't have it working just right yet, but soon, I hope, and maybe in the next few seconds, you'll get to see the fruits of my labor. I don't know. We'll see. So first, let's start off with seeing what our network looks like. So we're going to do an ifconfig, if I spell it correctly. Yeah, there we go. And it shows that we have a WLAN 0. That's what we're interested in. And you may want to make a mental note of the MAC address. Well, actually, I don't think I really care about the MAC on this one, come to think of it. But I think what we're really more interested in is in the wireless LAN. So we do IW config for our wireless configuration. And there's WLAN 0. And it looks good. Note that it says mode is managed. What we want to do is we want to put this into a promiscuous mode. So we want to turn on the monitor mode or promiscuous mode. So sudo AIR-MON-NG next generation. Oh good, I already have it in my memory here. Start WLAN 0. So you can kind of ignore some of the complaints because it'll say other items are using this, blah, blah, blah. That's fine, I don't care. It's not going to affect us. Now we want to IW config again. WLAN, oh, 0mon, there it is, and it's in monitor mode. No, it's working. Okay, good. That's a way to confirm it. Well, look at this is a learning process. But we want to, there we go, that's looking more like it. So now note it's going through the different channels and it's spitting out the MAC addresses. So these are the two columns we're interested in. The BSS ID, which is our access points. And then over here is the actual clients. And the one that we're gonna kind of look for right now is, I tried getting the light bulbs to de-authenticate and I really had no luck. So instead, we're going to attack my printer. Let me Control C out of this to get out of it. So I'm going to attack the printer. So down here, I happen to know that this is, well, it shows right here, that's the MAC of the printer. So here it is, 79, and that's who we're going to attack. I'm sorry, that's the AP and that's the MAC address. And when I say attack, I mean that's who we're going to de-authenticate. This is just for fun. Don't do this in public. It's illegal. You can get in a lot of trouble. This is on my home network. I'm just fiddling around. I don't condone hacking in that way, but it's good to understand how this works so that you know how to kind of protect yourself and what to look for in your logs. Or if you're doing packet captures and you see like, hey, what the heck's going on? Why do things keep coming up and down? This can be very helpful. So let's do a little more gathering here, a little more data gathering. Let's okay, so here we are. We're going to do an arrow dump-ng-d, the MAC address of the, now that's the MAC address of my access point, my router on channel 8, WLAN MON. And now we're getting a little more specific. We're not seeing everything on the network. We're only seeing what is specifically connected to that. And I believe, did I say 79? Yeah, that's my printer right there. So we're in the right spot. We have a little more info. We have actually all the info we now need in order to de-authenticate the printer. So let's do that, shall we? I think I have this in my buffer, so I'm just gonna kind of up arrow a bit. I don't feel like typing it all out again. As you may have noticed, I'm not the best typer. There we go. So this is interesting. So airplay-ng -0 is what we're sending. We're sending a deauth as -0. -1, I believe, is I can't remember, a reset, or I think I have that wrong, but that's okay. This 0 is the how many times. 0 means constant packets. You could pick 1 packet, 10 packets. This is the access point. This is the client, the printer, and that is the network. So away we go. Bang. So, right now, it is being attacked. I can't show you, but I'll show you on another screen. But note here, see, packets are being sent, ACKs, there's an ACK. So what's happening is it'll periodically drop on and off, and I will show you that right now. Okay, let's check it out. Here we are, and I'm refreshing the screen, and see HP, the 597876, that's the printer. Oh, it's thinking. I think we got it. Oh, see, it dropped. It is no longer connected to the Wi-Fi. Now, it'll come back though. It's going to keep retrying. See there, it's back. It's still there. Okay, let's see. Oh, I bet it's gone. See, it's waiting. It's waiting, and boom, it's gone again. So it'll keep dropping on and off. So I wrote another deauthentication piece of software for the ESP32 because it might be kind of cool to have it as a mobile. Now this again is very targeted to one client MAC address, and the screen isn't really refreshing, but it says client detected. I'm actually attacking the printer and it is knocking it off the wire, and then it reconnects. But it's a good kind of proof of concept. I'll show you the code, and I guess you'll just have to trust me that basically it kind of disappears from my Wi-Fi and then it kind of reconnects. But yeah, let me show you the code. Okay, so here's the code for, this is my version 3 of the deauthentication of a specific Mac. So yeah, I'm using my ESP32 from Adafruit. It's a Feather TFT. So I'm including the libraries. Here's SSID and password for the Wi-Fi. This has to do with my setting up the screen and printing to the screen. We'll just kind of zoom through that. I'll post the code on GitHub. So here's the first part of the loop. So it does a read, and if it's less than 1, you know, send something to this MAC address. Okay, and then basically I wanted, it's this ESP Wi-Fi deauth. Oh, when you mouse over, it's nice, it shows you some info. So it'll send a deauth, right? But I wanted to loop it, so if the packets are, you know, less than 2, send more. I'm going to kind of skip ahead a little bit here. This happens to be the MAC address of my printer. So I put that in there, and then also from the previous parts in this video, I showed how to get the BSSID, and maybe I'll post some of that in these comments, just, you know, command line tools to kind of find that. But basically, so we're sending different types of flags, and this is kind of important and interesting. So this is actually the kind of the packet breakdown, but CO is a deauth, and I made a little note up here. AO is disassociate, so I'm deauthing. How long? This is the broadcast. It's all bits are set, and now this is substituting this MAC. See how it says MAC? MAC 0 field goes here. This is field 2, etc. Just as a substitution. I guess we could have done the same thing for here, but I kind of never did it because these numbers change a lot. So this is the BSSID, sequence, and then the reason. And again, we're doing a deauth. And I gave, you can also say unspecified. And so this took me forever to get right, to get it right. So it's ESP Wi-Fi 802.11, which transmit, and then how to control it, and the size of the packets, and how to keep it working with this UINIT 8 versus 16 bits. Pretty simple code, pretty straightforward. Like I said, it just took me a while. Yeah, I'm a beginner. And then down here, it's interesting. It's the interface mode. That's it. Very short. Like I said, a lot of devices are pretty smart. The ESP32 is on 2.4 gigahertz. And the printer is on 2.4 gigahertz. That's why I was able to kind of deauth it. If something was on a 5 or 6G connection, you couldn't do it. So that's important to know. However, on the Kali server, which I showed earlier, that is running 5G, so you could, I'm sorry, with the Wi-Fi, so it could knock off something bigger, and yeah, so it's just kind of fun to fiddle around. I never really could knock the lights off. I kept trying. I'm either not doing something right, I'm not flooding them hard enough, or they're just very smart. Smarter than me. Okay, take it easy. And remember, don't hack, just fiddle around. I should say, I'm doing this on my home network. Doing this in public could be illegal in your area. You know, you can get in a lot of trouble. This is just to kind of see how it works, learn about it, have some fun, try to figure out how to make things work. I don't condone doing anything bad with this. I mean, you know, I guess there could be some practical things where maybe you have a bad client on your network and you just want to kind of kick it off. There's better ways to do it really than this, I think. But it's interesting. And again, it's always good to know how, you know, what's happening. If someone's hacking you and this sort of thing is occurring, you could do packet dumps and look at it in Wireshark and maybe, you know, kind of see what's happening and see if they're sending deauth packets. So this could be like, hey, wait a minute, this looks familiar. I see they're targeting this particular device. So let's look at it that way rather than let's, you know, hack around and do, you know, nefarious things. So have fun, take it easy, and only do legal things. Okay, bye.